This is the real Tom Rose, and this is a really interesting problem. We have to start out by doing some translation because we're given prose, and we want to convert that prose into algebraic equations. But we're going to have to finish it off by doing some interesting combining of equations in order to get our final answer. So let's start out by doing that translation. Let's see, a train ticket is $10 more for adults than for children. Here's going to be your first source of potential error. To write this equation, we know we're going to be equating adults and children. The question is, where do we put the $10 more, or plus 10? The way that I like to do this is I like to keep track of what the big and the small side of the equation is. So if it's $10 more for adults, adults are the big side, children are the small side. And if we're adding 10, we should probably add it to the small side if we want the equation to be equal to itself. Right? So the big side is equal to the small side plus 10. So that's how we know we've written this equation correctly and avoided error. The next sentence says, a group of 7 adults and 4 children pay a total of $235. Now, we've defined A as cost for adult, and we've defined C as the cost for children. So if we want to add up the total price, that should be total cost adults plus total cost children. And I should have written this as an equation. So let's move this over here. Total price is equal to the total cost of adults plus the total cost of children. So total cost of adults is going to be number of adults times price of adults plus the number of children times the price of children. All right, which will equal, they said 7 adults at a price of A plus 4 children at a price of C equals the total, which I'll call T. And we've been given the total cost is $235. So let's put that in instead. $235. Now we have 2 equations. A equals C plus 10 and 235 equals 7A plus 4C. 2 equations and 2 variables. So we know that we can solve this. That's one of your criteria for being able to solve using substitution. The same number of variables as equations. The question is, what do we substitute? It's very tempting to simply substitute C plus 10 in. But I'm going to do something a little differently, and you'll see why when we come out the other side. I'm actually going to solve for C. So I'm going to subtract 10 from both sides. And we'll get A minus 10 is equal to C. And I'm going to plug that in here. And watch, and you'll see why I did this. So I end up with 235 equals 7A plus 4 times A minus 10. So I end up with an equation that has only A's in it. Why is that useful? Well, what have we been asked to find? We've been asked to find the total cost of the ticket for 1 adult. We've been asked to solve for A. By substituting in for C, I actually have made it possible that I'll get the answer for A. So let me say that one more time. We're solving for A, so I actually want to substitute in for the other variable. And that's a nifty little twist. You don't have to substitute this way. You can always substitute and then plug in to another equation later, but you'll save time if you always solve for the right thing. So we're going to solve this for A, and we're going to end up with 235 equals 7a plus 4a minus 40, if I distribute the 4. Let's add 40 to both sides and collect like variables. We're going to end up with 275 equals 11a. Divide both sides by 11, and we end up with 25 equals A, which is answer choice C.